Hello everybody, we're getting ready to do SAT Math Level 1, Level 2 Prep. SAT Math Level 2 Prep, Lesson 1 or Section 1. Welcome everybody. And for our first lesson here, Part 2 of our first lesson, you got 12 points that will go into your notebook guide. And then 6 points will go into your classwork sheet. We cover definitions, combining piecewise, inverses, and odd and even functions. Name, date, period for my classroom. Due date for onliners, homeschoolers. And page 1 of our lesson. We'll start out with notebook entry here. If the inverse of a function is not a function, as in example 1, it can be made into a function by limiting the domain of the original function. In the example, the domain of f could have been limited to greater than 0, greater than or equal to 0, or less than or equal to 0. Then the inverses would have been radical x or the negative of radical x, respectively. If a point with coordinate AB belongs to a function, then the point with coordinates of BA belongs to its inverse. Therefore, the graphs of inverses are reflections about the line y equals x. This is illustrated for f of x equals x squared in the figure below. The inverse in this figure is graphed as a dashed curve. You can see that the inverse is not a function because it doesn't pass the vertical line test. Thus, a function does not have an inverse if there is a horizontal line that hits its graph in more than one point. So that graph, since the domain and range of inverses are switched, like this situation here, this graph here, which is the inverse, is not a function. It would not pass the vertical line test. Since the domains and ranges are inverses are switched, the range of a function can be found by finding the domain of its inverse. So that's kind of a convoluted way of finding domain and range, but you can use it that way. Like if it was just greater than 0, then this part of it would be a function, but when you add this to it, it makes it a non-function. Okay, so moving right along here to letter K, find the range of this function here, f of x equals 1 over x plus 4 minus 2. So using the method described in the previous examples, find the inverse to be the inverse of f of x will equal 1 over x plus 2 minus 4. So we've talked about how to find an inverse of a function. Since x equals negative 2, is not in the domain of the inverse of f, the value negative 2 is not in the range of f, so the range of the inverse of f is all real numbers except negative 2. Negative 2 won't work here. It'll make it a hole in the function. A function f is called even if f of negative x equals f of x for all x in its domain. For even functions, outputs are equal for opposite inputs. In fact, the designation even comes from power functions of the form f of x equals x to the n, where n is an even integer. So that's where your even functions definition comes from. The graphs of even functions are symmetric about the y-axis. A function f is called odd if f of negative x equals the negative of f of x for all x in its domain. For odd functions, outputs are opposite for opposite inputs. Again, the designation odd comes from the power function f of x equals x to the nth power, where n is an odd integer. The graphs of odd functions are symmetric about the origin. Functions need not be even or odd. A function such as f of x equals x squared plus x plus 1 is neither even nor odd. At the other extreme, f of x equals 0 is both even and odd. Even and odd relations are similarly defined. A relation is called even if negative xy is in the relation whenever xy is, and is called odd if negative x, negative y is in the relation whenever xy is. The unit circle at x squared plus y squared equals 1 is an example of a relation that is both even and odd. The sum of even functions or relations is even, and the sum of odd functions is odd. The product of two even or odd functions is even, while the product of an even function and an odd function is odd. So we're coming up with a lot of terminology in here, a lot of concepts that are being hashed over. And I do have packets that I can issue you to brush up on even and odd functions. Okay, let's try an example here. We got this graph here. L for f of x equals x squared and f of negative x equals the negative x squared equals x squared. Therefore, f is even. So this would be a situation here where this function here will be an even function. And then this situation here, we have m, f of x equals the absolute value of x, and f of negative x equals the absolute value of negative x equals negative 1 times x equals the absolute value of negative 1 times x, which equals x. Therefore, f would be an even function by that definition. Then this situation here, f of x equals a cosine x is an even function because cosine of negative x equals cosine x. Then this situation here, f of x equals x cubed, and f of negative x will equal the negative x cubed, which equals negative x cubed. Therefore, f of negative x equals x cubed, which equals the negative of f of x. So f would be an odd function here. This would be an example of an odd function. Then this situation here, f of x equals 1 over x, you get this hyperbola going, and f of negative x would equal 1 over negative x, so 1 over negative x over here. Therefore, f of negative x equals the negative of 1 over x equals the negative f of x, so f would be odd. This would be an odd function. And then we go back to this again. F of x equals sine x is odd because the sine of negative x equals the negative sine of x over here. A piecewise function is a function that is defined by different equations or different parts of its domain. Piecewise functions provide useful illustrations of calculus concepts, but they also occur in real-life situations. The function f is defined by f of x equals these parts here of a function. X less than 1, x greater than or equal to 1 for x squared and x plus 3. Find f of negative 5, f of 1, and f of 3. So f of negative 5 would equal negative 5 plus 3 equals negative 2 for this situation up here. F of negative 5 be negative 5 plus 3, so it would equal negative 2. And that would satisfy x is less than 1. And then f of 1 in this situation, it'd be 1 squared would equal 1. Then f of 3 would be 9 for here. S, a store that makes copies charges 25 cents per copy per page if 50 or fewer copies of each page are made, 20 cents per copy if between 51 and 200 copies of each page are made, and 15 cents per copy of more than 200 copies of each page are made. How would this be written as a piecewise function? So how would you write this as a piecewise? So here it is, 0.25x, 0.20x, and 0.15x with these limitations over here. X less than or equal to 50, 51 to 200, and then over 200. You have your different pricing there for that. In this example, x would have to be a counting number, so meaning like an integer counting number. So t here, find the range of this piecewise function here. Find the range. F of x equals 2 to the x of x is less than or equal to 3. And then we have x squared plus 1 of x greater than 3, and write it in interval notation. So to find the range of this situation here, the range of 2 to the x for x less than or equal to 3 is 0 is less than y is less than or equal to 8. And the range of x squared plus 1 for x greater than 3 is 10 is less than y is less than infinity. The union of these two ranges in interval notation would be 0, 8. We'll open interval here, 0 and 8. In union with 10 and infinity, there is a gap between 8 and 10 in the range of this function. So between 8 and 10, the function would not exist. And that is section 1, part 2 of SAT Math Level 2 preparation. For study packets and other materials, animated PowerPoint math video at AOL.com. And thank you very much.